We've got the Yamaha R-N2000A network hi-fi receiver, bench test results. That's what we're going to be talking about in today's video. Hey folks, I'm Gene Delasello with Audioholics. I know you guys have been waiting a long time on my R-N2000A bench test results. Last year I did some coverage. We had Kumasawa-san from Yamaha, head of hi-fi, give us demonstrations of the 5000 series, the 3000 series. They brought one of these 2000 receivers, and I asked if I could hold on to bench test it. It turned out it was a prototype piece and there was some problems with it. So it took me a while to get a new sample, and I got it back in and I did the bench test results. I'm going to share that with you today. I want to show you, first of all, how beautiful this receiver is. I've never seen a 2-channel receiver built better than this or better crafted. It's just absolutely stellar. And when you see it in person and you touch it and you feel it, there's something to it. It's a callback to the 80s of Yamaha hi-fi. It's their heritage. It's what I remember growing up when I was a kid. I aspired to have equipment like this that I couldn't afford. And I just love the look of it. So it comes in black, and the unit I have is in silver. And it's just beautiful. I love the VU meters on it. It's multifunction VU meters. All the dials on it feel like really good quality. There's bearings on the volume control, so it's very graduated and very smooth when you're going up and down. Much different tactile experience than the 1000A, which I loved that receiver as well, and it bench tested excellently for what it was. But that's an $1,800 hi-fi 2-channel receiver. This is a $4,000 one, so this is over double the price. And what do you get for double the price? Well, that's what I hope to show you in this bench test result. But I'm also going to do follow-up videos. I'm going to do some listening tests. I'm going to test the YPOW. I'm going to test this amplifier under various different loudspeakers and compare it to the 1000. So it's not just about the bench test results, but it's also about the listening tests, which I like to correlate both. You can't just live off of one or the other. It's a good complement to each other. So without further ado, I have a really detailed written report. I'll put a link in the description below. You should read the report. But I want to go over the key aspects of my measurement results so you guys better understand what's going on here. And it just gives you a better appreciation for what Yamaha was set out to strive for when they designed this product. So I'm going to share my screen here now and basically just go over this with you guys. And just to show you the specs, it's 90 watts a channel. That's what it's rated at for 8 ohms, both channels driven, full bandwidth. It's a beast. It weighs almost 50 pounds, and there's a reason why it weighs that much. Not only does it have a really big power supply, but it's got a lot of heatsink area, and I'm going to show you the insides of that so you understand better what I mean. It also has a very high-end DAC. It's got the ESS Sabre DAC. I think it's the 9026, so it's a better grade DAC than what's on the 1000, and it has an incredibly high-end Phono preamp, and I have measurements to show you about that as well. And here's the back of the unit. It's just beautiful. I mean, everything, all the connections on it are excellent. It's got a USB-B, it's got coax, Toslink, it's got HDMI ARC. Of course, it's got all of your analog inputs. It's got a subwoofer output with bass management through Yamaha MusicCast app. And it's got 2 sets of gold-plated binding posts, really high-grade binding posts for your speakers, and those are wired in parallel. So you can actually plug 2 pairs of speakers in at the same time. It'll draw twice the amount of current. And this amplifier, even though it's 90 watts a channel rated, this amplifier has gobs of current. And I'm going to show you more about that in a minute. So here's just a top view, and just look at this to appreciate what's behind the R-N2000. It's what I call an exercise in over-engineering. You look at this product and you're like, how is this only 90 watts a channel when it has much more heatsink area than you're going to get in an 11-channel receiver? The power supply is way bigger than you're going to get in a big AVR. So it's those 4 output capacitors and that big toroid. It makes for a very stable power plant. And it's not just the power plant itself, it's the amount of heat dissipation that this thing is able to achieve without it getting overheated. I mean, I've torture tested this amplifier, and it never complained. It never got overheated. It just got warm to the touch. And part of that is the amount of heatsink area that they have there. They're also using very high grade MOSFET output. So there's 4 output devices per channel. This is not a BJT output device like you get with the 1000 or their other AV receivers. So just go over the preamp first. I think it's important to look at the preamp outputs in case, let's say down the road, you get these giant tower speakers that just need gobs of power that you can't get with this unit. And you want to use this as a preamp because it's got a really high-end DAC. It's got a really high-end phono preamp. How good are the preamp outputs? And that's what I want to show you. So using the analog input path, I compared the pure direct versus non-pure direct. So when you have pure direct engaged, it disables the tone controls, it disables the DSP, it disables the analog to digital converters, all that stuff. And if you look at the measured output voltage versus distortion, I compared the pure direct versus non-pure direct. The pure direct, of course, was significantly better, at least in the measurements. I'm not saying that this is 100% audible because you're already down in the mud. This is really low distortion to begin with. We're talking the difference of tenths of a percentage of a decimal point on the distortion graph here. But if you look at this graph, let's look at the pure direct for a moment. Really low distortion. We're talking at 0.002%, like in the 90 dB SINAD area. When you get past about 1.14 volts, you start seeing the distortion go up a little bit. And I believe the reason for that is because even though you turn off the power amp, if you turn off speaker A and speaker B, those power amps are still engaged. And what's happening is when you get to about 1.14 volts, the power amp sees full power. And I believe that when you're cranking this thing beyond clipping, some of that distortion is getting back into the preamp section. But we're still talking down in the mud. So even close to 4 volts RMS, we're still at under 0.01% THD plus N. So this thing has plenty of preamp output voltage, and it's very clean. Like I was saying before, when you're in pure direct mode, you're at like 0.005% under most operating conditions. It's good preamp. And if you look at the FFT at 1 kilohertz in pure direct, I mean, the second order harmonic is like 103 dB below the fundamental. That's really clean. The preamp output's really clean. I don't see any ground issues or anything like that. It just looks really nice. Now, I also use digital inputs, and I checked the FFT on that. The FFT was a little higher in distortion than the analog input, but still very good. The third harmonic is now the dominant in the distortion profile, but it's 95, 96 dB below the fundamental. That's using a minus 20 dBFS input signal and getting, I believe, 2 volts out, or no, I'm sorry, 1 volt out on the output. But when I went to 0 dBFS, which is full digital full scale, and I set the volume control for 1 volt output, the distortion, the FFT spikes went up a little higher. So we're at like minus 88 dB. That's not great. I mean, it's not horrible. I would have preferred not to see the distortion go up like that, but something like this is definitely inaudible when you're talking about below 80 or 90 dB. It's just something I wanted to bring you awareness to. Not a big deal, not a game changer at all. And if you look at the frequency response of the analog input path, actually, this is with the digital input at 192 kilohertz sampling rate. Its minus 3 dB point is like at 80 kilohertz. So it's a very wide bandwidth preamp, very clean. And what I did was I ran a 24-bit 192 kilohertz input, and I measured the dynamic range of the DAC, and I got 117 dB. So that's like almost 20 bits of resolution, like 19 and a half. That's really good. That's about 6 dB better than when I measured on the R-N2000A when I did similar test scenarios. Then I looked at the outer band on the DAC at a sampling rate of 44.1 kilohertz. That's the most important one to look at because that's CD. And your out of band behavior will be more prevalent there because you're at a lower sampling rate. And you could see above Nyquist, this is clean as hell. The out of band is completely clean. There's no spikes. It's down in the mud past 30 kilohertz. Just excellent. That's just excellent engineering right there. And I ran that with 192 kilohertz and 96 kilohertz sampling rates. I got perfectly good responses as well, right at 1/2 Nyquist. And I wanted to show you the Phono preamp. This is what I was really impressed about. So when I measure the analog phono preamps of different products, I sometimes get different results, even though I use the same equalization curve. I measured some products where they actually put a subsonic filter that's non-defeatable and it rolls off pretty sharply below 20 hertz. The Yamaha and some of the Denons that I've measured and some of the Marantzas, they don't do that. They give you full bandwidth here, which I prefer. I'd rather add a subsonic filter if I need it, not have it forced on me. And this is really clean output. So it's a moving magnet phono preamp, and the typical voltages for those kind of cartridges is anywhere from 3 to I think 6 or 7 millivolts RMS. I typically test right in the middle at 5 millivolts. Believe it or not, I've measured products that had really high distortion when you got to 5 millivolts, like beyond 3 millivolts, and the distortion went way up. And some of them just didn't look great on the graphs. This preamp, this phono preamp, was allowed me to drive it up to 50 millivolts, which is way beyond what any moving magnet cartridge is going to give you. And it was clean, really clean. The response was clean. It was flat, again, out to the limit of my test gear. I ran a distortion on it here. This is with a 5 millivolt in 1 watt output. That's at the speaker outputs. Look at how clean this is. This is just beautiful. Low distortion, really low distortion. This is one of the best phono preamps I've ever seen. And just to show you how good it really is, I ran it. I basically set up a scenario where you have a turntable all the way to the loudspeaker. And from the input of the phono all the way to 1 watt on the loudspeaker, I always measure all SNRs at 1 watt, so everything is comparing apples to apples. I got 80 dB SNR A weighted. That is incredible. That's something I see typically from like a good amplifier. So the fact that I ran this through the phono stage and then through the amplifier and got this number here on pure direct mode, this is just excellent result here. And this is what I heard when I was listening to this receiver in a real room with my speakers and different source material. I heard very low noise. Really almost like the black levels on an OLED, just really inky and really subdued in noise. And I'll talk about that when I do my separate listening tests. So let's go moving on to the power test. So now the FTC has a new amplifier rule as of August 2024, 16 CFR part 432. Not a big fan of some of the verbiage in there. They want everything tested at 8 ohms. They want power tested at for 5 minutes. And they want a preconditioning period. So the preconditioning period I'm okay with. In fact, the old rule used to be 1/3 power for an hour. And that proved to be too difficult for most receivers because that's where in a linear AB design, that's where it dissipates the most heat. It's the least efficient while delivering that much power. And it could send amplifiers into thermal protection and shut them down. So I'm supposed to test it at 1/8 power for an hour, but I knew based on the engineering of this receiver that I could torture test this based on the 1974 FTC rating. That's what I did. And I tested it for an hour straight at 1/3 power. And after an hour, not only did it maintain very stable power, but I put my hands on top of the unit and it was just warm. It wasn't hot. It never got hot. And the funny thing is I compared my amplifier measurement power results precondition versus post-condition. And the Yamaha actually delivered more power after the post-condition. And so when everything was properly biased, the amplifier got better in performing. And I spoke to Yamaha about that. And they actually told me it's normal to warm this amplifier up. Like you want to warm it up a good half hour or so to do your real critical listening because everything gets biased properly. And then it gets that really nice sound quality that you expect from a Yamaha. So I thought that was very interesting. So what I did was the FTC rule is very vague about how to test for 5 minutes. Do they want to test at full bandwidth or do they just want to test 20 kilohertz, 1 kilohertz, 20 hertz and randomly check it for 5 minutes and make sure it reaches that power? A lot of problems with that on doing that kind of test because now you're limiting the amplifier power in most cases to 20 kilohertz. And in some cases, like Class D amplifiers, they won't do 5 minutes on because of their output filters and they're going to power limit. Topic for another discussion. I did a video on that if you want to look at the FTC rating. But what I did here was I torture tested this receiver. This is not something I would do with an AVR. I did what's called a regulated power sweep. And what I did was I set up a script in my Audio Precision where I set it so it would change the input signal, vary it up and down, and measure in 1/3 octave increments from 20 hertz all the way to 20 kilohertz. and raise the level just below the distortion threshold, which is 1%. And you can see here I have a dotted line at 1%. I ran this thing. It probably took a good 5 or 6 minutes to run this sweep, and it delivered 100 watts of channels, both channels driven full bandwidth at 1 to 1% distortion. That's beyond Yamaha's 90 watt per channel rating. And this was a torture test, and the 2000 had no complaints. It was just, it swimmed along just fine. I also ran it at 4 ohms, 2 channels driven, and I got 165 watts, and that was at under 0.1% distortion. So this thing has really good power, very stable power at full power bandwidth. This is a continuous full power bandwidth rating. And when I look at the FFT at 1 watt, it's not perfect, but it's very good. So if you look at 1 watt, it's odd order harmonic distortion is dominant. It's about 84 dB below the fundamental. I've seen some amplifiers get in the 90 dB range, but 84 is perfectly fine, perfectly inaudible. I saw a little bit power supply hum after the rectifier circuit. I'm guessing it could be some leakage in the transformer, but it's down around minus 90 dB. I'm not going to cry over it. And I want to show you the power sweep test. So I did the typical 1 kilohertz power sweep test, and this is with 8 ohms, 2 channels driven. What I love about this graph is Yamaha rates power before the knee of the graph, not after the knee. Most AVR receivers are rated after the knee. I love the fact that they're conservative, and the knee is right here at 100 watts. They rated it at 90. And look at how linear that response is. So with 1 kilohertz at 1% distortion, it got 120 watts. With both channels driven at 0.1, it got 110 or 111 watts. That's really good. I did that as well for 4 ohms and got 178, 179 watts at 1%, 148 watts at 0.1% with both channels driven at 4 ohms. Again, look at how linear that response is. Some amplifiers or some AVRs, when you run them at 4 ohms with their current protection coming in, you get some real funky response in the vertical area here from all those protection circuits. There's none of that here. And in fact, there's no dreaded impedance switch on this receiver. No impedance switch, so don't worry about that. And I'm really happy not to see that stupid impedance switch. And then I did something on a receiver that I almost never do. I tested it at 2 ohms. And there's not even a spec in Yamaha's website about what it would do with 2 ohms. And this thing put out some good power. We got almost 288 watts a channel at 2 ohms with both channels driven at 1% and 258 watts at 0.1%, both channels driven at 2 ohms. And at no point did I hear this misbehave. I didn't hear the receiver strain to deliver 2 ohm power. It just did it without complaint. And there are some products that I've tested. You can hear piezoelectric effects within the electronics. So they get resonance from these test tones, especially when you're really stressing them out at high power. The Yamaha was so quiet, so stable, no resonances, and it's textbook. And that's what I love to see when I measure an amplifier. And that's what gets me excited about doing these kind of bench tests. So I ran some dynamic burst tests, which simulate more music program material. At 2 channels with 2 ohms load, we got 360 watts. Again, this thing is very powerful for a 90 watt amplifier. It's got some serious high current capability. So I ran a power table test for anyone that's wondering the differences between the 2000 and the 1000. Now, granted, the 1000 is actually rated at higher power. So that's why you're seeing at 2 channels driven, the 1000 has a little bit more power than the 2000. But what you see when you get to the 4 ohm area is you see some advantages to the 2000, especially when it's being held constantly for 5 minutes. So I didn't even check the 1000 at 2 ohms. I was too concerned to drive in that receiver, and I'm not sure if it would be able to handle it. So there's no results there for the 1000, but the 2000 happily took the 2 ohm power and delivered it. So on the surface of just looking at these bench test results, it looks like the 1000 is more powerful, but I'm telling you from experience, the 2000 is a much more stable platform. It loves delivering high continuous current at low impedances, which is very important if you choose speakers that have low sensitivity, that have low tuning, so they have a lot of bass, and they're a lower impedance. And that's what I was talking about, that I'm going to be testing this extensively with the R-N2000A bookshelf speakers. Those are a really difficult speaker. In fact, when I ran those speakers on my Cambridge Audio EVO 150, that amplifier sounded great with my Revels because those were higher sensitivity speakers, 91, 92 dB. But the Arendals were only 84.5 dB, and they're 4 ohm, and they're tuned down to 22 hertz. They actually have more bass extension than my big tower Revels. It did not do well with the Cambridge amplifier. The amplifier was overloading. It sounded very forward. At first, I thought the Arendals were a bright speaker in my listening room. Then when I switched over to this Yamaha 2000, it just sounded so much more effortless. It sounded more laid back, more warm. And as I cranked it up, I just heard gobs of bass, gobs of clean power. That amplifier sounds way bigger than what you're seeing on this bench test. And it's all because it's got a stable power supply that could dissipate that heat. It doesn't build up heat. It doesn't cause sag in the voltage. In fact, when I did this bench test, whether I checked one channel or two channels driven, the power was virtually the same. And it's almost like the power supply was regulated. And I actually emailed Yamaha. I go, do you guys doing some regulation? Because you don't typically do regulated power supplies with linear supplies on linear amps because it's very inefficient to do that. You lose lots of power through drop-off voltage of the regulators. What Yamaha did instead was they put so much power supply capacitance in this thing. I think there's 4 times 18,000 microfarad capacitor bank as opposed to 2 times 12,000 on the 1,000. And because they have so much power supply capacitance, not only do they lower the ripple voltage, but they've minimized the effect of power sag. So even though it's not a regulated supply digitally or through traditional regulation, it's got such a stable power plant that has so much power reserves that it never lets that rail voltage drop, no matter the load impedance. So it's acting close to an ideal voltage source as a result. And that's what we saw in the results here. And that's what I heard when I was driving really difficult speakers like the R-N2000A. So just to go over the signal to noise ratio, I love doing this kind of test. I do this with a digital input of 0 dBFS, and I measure all the way through to the output at 1 watt. The Yamaha super quiet 92.5 dB SNR. That's really good. That's better than I got, about 2 dB better than I got on the 1000. And the 1000 was already quiet. So that's a good result. Ran a square wave through. I didn't see any phase inversions. Everything looked clean. There's not, any appreciable overshoot or undershoot. That's just a clean form there for anyone that likes to see the square wave test. And yeah, I love the VU meters. I just think it gives a touch of class to the product. And I like the black one too, to be honest with you. If I was buying this, I'd be on the fence of whether I'd get silver or black, depending on what matches in your rack. I do like the callback to silver, from the 80s golden age of hi-fi. So with that being said, overall, I would say that this receiver delivers more than promise. It's got a super stable platform, just like there are other products in the hi-fi line, like the 3000 series and the 5000 series. This brings you a lot of that performance with the float and ground technology and the MOSFET outputs and the toroidal and the symmetry and the power supply and the heat sinks and all that stuff. So you're getting all that resonant control, all the great build quality. That's a lot of features, a lot of tech, a lot of craftsmanship in a product that's $4,000. Yes, that is a premium price. But when you think about everything that's in this, it's definitely my favorite receiver right now for 2-channel. Now, I want to be testing out some more in 2025 to see how it compares to this one. But right now, this is going to get our Product of the Year award for a 2-channel receiver because it just does so much. You could hook this up to a TV and you could have yourself a whole entertainment system that will rival any entry-level 5.1 system and certainly any entry-level or even the higher-end sound bars too. So if you want to have really good hi-fi 2-channel experience and plug it into your TV so you can do all your streaming and then use MusicCast to do all your music management and use Tidal Connect, you have it all at your fingertips, and especially that really high-quality Phono preamp stage. I was really impressed with that. So guys, if you like this video, please hit thumbs up, hit subscribe. Don't forget about our Patreon channel at patreon.com/audioholics. We appreciate your support. You get direct access to me if you want to suggest video topics. And by the way, we're giving away an R-N2000A. Yamaha is sponsoring this contest. So please enter to win. I'll put the description, I'll put the links in the description below. You guys can enter if you're in the United States. I would highly encourage you to enter before December 31st. That's when the contest ends. And I wish everybody good luck. And until next time, my friends, keep listening.